Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about the workflow in going through and setting up a mooring analysis for something like a barge system in waves and currents. Um, we're going to start off with a hydrodynamic model of a barge here. This is a little 20 meter by 20 meter by 2 meter box barge that we've used in a few other video tutorials. And I've got a project, ProteusDS Simulation Toolbox project set up with a hydrodynamic model, wave radiation, diffraction, and excitation already set up and ready to go. So we're going to use this as the basis for adding a spread mooring and going through the adjustments and analysis process and just show what that workflow looks like from the start to the finish. So the project I have here has the rigid body set up in it and the hydrodynamic model configured. We want to go from here to setting up the mooring model, going through the analysis process and reporting. So the first thing I'm going to do is make a copy of this project, and we'll just call it mooring setup because I want to play with adding some moorings to it and just keep things nice and separate. And I'm going to open the visualizer window here. I like to have the water surface on for reference. So we're going to make a 4-point spread mooring around this this barge. And you can see we have a water depth of 50 meters. We're just doing a little kind of coastal system here. And I'll show you how to get the geometry set up, and then we're going to add some material properties and then run some analysis. So we're going to use under configuration and assistance, the Taut Mooring Assistant. And we'll click confirm on the one rigid body that we've got here. We'll keep things really simple and keep everything doing a single cable. Node 0 acts as fair lead, that's just connecting which end of the cable to the rigid body. And we'll go add mooring here. And I'm going to keep it really simple and just attach everything on the 4 corners of the barge. So we'll do 10. This is in terms of the rigid body frame, 10 and 10. Azimuth angle 45, and I've done a little bit of thinking about this in advance to get the scope and the angle and everything that I kind of want. It's not always obvious what it is, what's going to work. I mean, this is obviously giving you a chance to explore different material properties and configurations and see what's going to work. So this is just doing a straight line. We're going to let it relax as we apply chain and rope and material properties to it, and I'll show you how that works. So this is just getting a starting point here. So we've got the first mooring line done. We'll do the second mooring line here. Let's see, where's my X there? So we want to do minus 10, 10, and 135. And well, I can adjust the elements later as well. I do like to have a few elements in there just for visualization. So those white dots are the nodes in the finite element mesh. And we'll go minus 10, minus 10. Azimuth angle of 225, 5, 10, and there's the other mooring line. So the nice thing about the Taut Mooring Assistant here is it's going to create all the cable D objects and the connections. You can certainly go one by one and create each one. It's a little bit nicer to go through this interface and set them up this way though. And 315, 5, and 10. And we're done. So we've got our spread mooring set up here. Now this is just the geometry, so you can see it's made the cables for us, and you can see it's got all the connections and everything that we want, which is good. Now the problem is we don't have the material properties set up here, and obviously this is not a valid it's not going to have any kind of valid pretension, so we want to check this really quickly. So how to get the properties in here? There isn't a set of stock material properties in here. So what we'll do is I'll show you how to do that. We go to the parts editor, ProteusDS parts editor, and I'm just going to pick something really simple here. We'll pick some polyester, premium polyester Samson. So you click on that in here. Of course, you can do search and find different things in here in the parts editor. What you want to do is go view selected part in ProteusDS input format, copy to clipboard, and we'll go here and add a feature to cable segment, polyester 40 millimeters, and you can hit Control A to select all and just paste it over that. And we're going to add, so we're in the library view here. Another way you can do this is go do the same thing here, and I'm going to grab some chain now, so we'll close that here. And under chain, I think we have quite a lot of sizes here for chain, so we'll just grab some 32 millimeter chain. Again, copy to clipboard, chain 32 millimeter, and I'm going to paste it in here. So now I've got those material properties in my project here. So there's another video on how to fine-tune the pretensions. That's a little bit of a process. There's a faster way that you can sort of approximate them really quickly, and I'm going to show you how to do that now, which you'll get a feel for with a little bit of experience in playing around with this. So we're going to look at and go through each one and click on state. We have the old cable segment mode on here, so we'll change that to cable segment mode 1. Resolve follower properties. This should be the default in all of them now. It's just an older project I had set up for this. There we are. So we'll go to state now. What we want to do here, here's where we establish the geometry, which is going to show up as a blue line. We're just going to give the geometry a tiny, tiny, tiny amount of extra length in here, and it's pretty shallow, so it's not going to make very much of a catenary belly, even with just this little bit of extra. This is 1.0025. There's a little bit of a bow there, but with lifting up that chain, it's going to make some pretension in the mooring, and you'll get a feel for sort of like, you know, what value works for what kinds of projects you're working on. This is kind of a nice option, eject nodes from the seabed, just in case any are penetrating in there. As a habit, I like to do that one, so we're going to go OK. It's going to say, hey, there's a slight difference in the length, and we're going to click no, we want to keep the same overall length that we've specified. Now, what you want to do here is specify the material properties. So starting from node 0, we're going to have some polyester, and after that, next to the anchor, we want to have some of our 32 millimeter chain. What I'd really like to do is have on the order of 5 shots of chain. So that's 150 meters. It's roughly about 30 meters per shot of chain. You might want to have sort of a good element density in there. That might be a little bit high, but that's pretty good for element lengths. And then the rest of the line is going to be made up by the nylon, so you can click resolve on this, and then it just automatically picks the rest of the line lengths for that, and those element lengths are probably pretty good. And you can see we've got a little bit of a bow here, shape, a little bit of a catenary, and then you can't see the transition from chain to fiber rope here, but it is in there. You'll see a green node in the simulation results. So we're going to do exactly the same thing with all the others. Yes, I'm just going to put in that 1.0025, eject nodes from seabed. I don't want you to adjust the length. We're going to go after this, set the chain, 150, 10 elements, resolve this one so it's automatically adjusting this. Oops, we should change that to the polyester. We'll apply that. So we did that mooring line. We got to do the 2 remaining mooring lines. So we'll do exactly the same thing. Set the chain. Change this to polyester. Apply. Eject nodes from seabed. Add the chain. resolve, and we are good to go. So there's our mooring. I have a feel for how this is going to work, and we'll save this. I don't have any currents or waves or anything turned on here, so when I run this, you can get some feedback on what the actual pretensions are going to resolve out of this. Now, normally what I would do is let it settle, and you could start, this is not too far off from a settled result though, from experience. So what we'll do is we'll just take a real quick look at it here. Okay, it's finished running. So there's our mooring lines in rendered view. We'll turn this on in engineering view, and in ProteusDS it changes it shows a green node when the material properties change. So this is all the polyester, and then we've got 32 millimeters of chain here, and you can see the heavy chain pulls down the mooring, and then that's going to lead to some pretension in those lines. So what you want to keep an eye on, of course, is making sure your fiber ropes are clear of the seabed, as well as during the dynamic analysis, right? So this is a nice comfortable kind of distance off there, and then if we click on plot tension versus time, in fact you can click on all the moorings to see what they all look like. We want to look at node 1, and we're getting to sort of like 33 kilonewtons of pretension, which is, depending on what you're doing, that might be a good amount, it might be a little bit high, it might be a little bit low, it sort of depends on what you're doing. The higher the pretension, the more it's going to kind of be restricted to staying in one place, and it just really depends on the condition of what you're looking at. So we could, this settled actually really fast. If we look at this again, within 10 seconds, it's kind of at its pretension, and then absent any other currents and wave conditions, like that's what it's going to do. So I don't really have a problem with. You could export this final state and use it as a starting point, but I mean you should really be looking at a pretty long simulation with waves and currents. So and ignoring that sort of ramp up time. So what I might do, I'd like to make copies, and so we've got the results anyway. We might as well export. It's like making a copy, and we'll do currents, waves. Now it's going to take the final state and use it as a starting point. Again, if you wanted to fine tune that pretension, there's a way to do that, which we show in another video. Now, what we want to do is environmental transition mode on. We want to make sure that we've got wave transition mode on, and current transition mode. You can do these things separately, which is kind of nice. So I want to turn on my waves, say at over the course of 10 seconds, start at 30 seconds. So this will allow me to turn on the current at 0 seconds and take 5 seconds to ramp up the current speed that I want to use. I'm going to keep it real simple with a linear shear current profile. You might want to use something conservative like a uniform current profile, but we'll just do this. Say we'll line everything up with one of the mooring lines. Current speed of 1 meter per second is kind of high for coastal area, but let's just run with that. And we'll do John swap, 4 meter, 10 seconds. So the way that I've configured this is the waves are going to start ramping up after 30 seconds, and they're going to take 10 seconds to do that. So this way you can do everything in kind of one simulation and just ignore that first kind of minute of analysis. So we'll do 750 seconds, and we should be good to go. We've got a separate project here, and we'll let it run. Okay, what we're going to do is I'm going to look at some results that I computed ahead of time, which are pretty much the same as what we looked at. Slightly different currents, slightly different wave periods, but the main thing is I wanted to show the workflow. So after your simulation results are done, it's always a good idea to take a peek at them in ProteusDS. This is a handy thing to do to specify times to load. It'll just take a little bit less time to look at the whole thing. So we'll just load a subsection of that time. So can look at engineering view, and it sort of shows things a little bit easier. If you like, you can show the tension range in here. So you can see there's the barge riding through the waves, and there's a current imposed on top of that as well. This plotting feature is really nice to look at all of the line tensions together in one plot. And this is at the top, not at the bottom of the mooring. It's only showing what we've loaded here, but it's really nice to get some idea of the variation. We're not seeing any that are at 0. It's nice to see all this visualization and check on things. Remember to keep an eye on the fiber rope distance from the seafloor and stuff like that as well, which you can do through probes and things like that as well. But to post-process it, we have a legacy report tool here. So here's where you want to pick rigid body mooring. And there'll be an option here, the report start time. That's when you want to pick something like 60 or 100 seconds to kind of ignore the statistics of those initial ramp-up times and transitioning times from waves and stuff like that. And so we'll click generate. And what you'll get out of this is a nice summary. It's in an HTML format, but it gives you all of the maximum loads in the moorings. If there's minimum breaking load information for the material properties that you put in, you'll get some information on that as well. So it's echoing back the inputs here. We look at the minimum safety factors from the different mooring lines. You can see where minimum safety factor looks like it's 3.62, which is a nice solid high number. And then there's more information on the loads near the anchors and so on and so forth. So this was intended to give you sort of an idea from the start to the finish of a barge mooring analysis in ProteusDS Simulation Toolbox, given that you had already set up the hydrodynamic model for the floater. And I hope that's helpful to you. Thanks for watching.